Okay, I'm doing this slightly different than the way your book has it, simply because I think including the units, especially after all this practice with dimensional analysis, it's going to make a little bit more sense than randomly dividing by something. And so one of the examples, we're going to use Avogadro's number to figure out the mass of an atom. And the example question says, what is the mass in grams of a calcium atom? So again, going back, we look at our periodic table. You'll see I already wrote it down. That the calcium atom is 40.078. So the way we can read this now is it's 40.078 grams per mole of calcium. So that's what I've written here. There are 6.02 times 10 to the 23 atoms per mole. So if I want to get to grams, let's rewrite this. 40.078, make sure you can see it good, grams per mole, times, now if I left this in this form, I would end up with moles squared on the bottom, grams times atoms on the top, so my units wouldn't work at all. I need to flip this. Per mole, grams calcium. Actually, we should make sure that we include that. Per mole calcium. And there are 6.02 times 10 to the 23rd calcium atoms. So let's check. Do our units cancel? Moles of calcium, moles of calcium. And I want to get to grams per single atoms. So you notice that this didn't cancel out. That's fine. And I'm going to get the mass per atom, which is what I want. So this works perfectly. And when I'm done, I get 6.66 times 10 to the negative 23 grams. Now you notice I truncated this, so the better habit that I should have taken for you is to take out Avogadro's number to at least 3 decimals to match what's on the periodic table. But truth be told, the vast majority of people use this, therefore limit this to 2 sig figs. So there you have it. That's how much one calcium atom weighs. Tiny. So now, let's use it for something that we actually do a lot of, because you remember we just did stoichiometry, and so one of the things that we always want to know is how in proportion do things go together? How many moles of something do I have? How many moles did it take for some certain reaction? So while it's good to have this practice, let's do something that we will actually use a lot of. So one of the examples in your books says that we have 0.909, I'll put the 0 in front, moles of hydrogen peroxide in 1 liter of gas. I'm sorry, a liter of solution. They want to know what the mass of the hydrogen peroxide is in that given volume of solution. So first thing is to focus on the fact that it's going to be in this volume, so we're not going to do anything with that. We want to know what the mass of this is. So the first thing I need to do is turn this into grams. So we're going to go to the periodic table, and it's going to be 2 times 1.008 for 1 mole of hydrogen, and then oxygen is 2 times 15.999. See, I'll practice good habits for you. Let's see what that comes out to. Okay, so check our sig figs. Remember, these 2's don't count towards the sig figs. So I have 1, 2, 3, 4 here, 1, 2, 3, 4, so that stays 2, 5, 2, 4, 5. So 3 after the decimal here, 3 after the decimal here. We're adding 3 after the decimal. So our H2O2, make sure you can see that good, H2O2 is 34.273 grams per mole. We have 0.909 moles. We want the mass. So let's start with this. 0.909 moles of H2O2 times, now mole needs to go on the bottom, 1 mole H2O2 and 34.273 grams H2O2 equals, moles H2O2 cancel out, and I'm going to be in grams of, oh bummer, I hate when I did that. So I hit pause, and I need to remember why I hit pause. So I'm going to talk my way through this one more time. We came up with the 34.273 grams per mole. We said, okay, this is where the sig figs are from here. And then we came down here, took our moles of H2O2, and multiplied it by our new conversion factor that we came up with above. Canceled our moles out and came up with grams of H2O2. And I'm thinking the part that you missed that I was emphasizing is it's really important that you say moles of what everywhere and grams of what everywhere. We're going to have more than one compound very, very soon. And if you don't have this habit and you to carry through with you as things get more complex, it's really going to bite you. You're going to start canceling out moles and grams of things and think you should have the right answer when you have the wrong compound in units that wouldn't have canceled out in the first place. So please, 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 always make sure you denote grams of what and moles of what. And so our final answer was 31.26 or 2 grams of H2O2 in that liter of solution. And that is your first mole conversion.